Hi, I'm Melissa Hartwig, and I'm going to be doing an example of a homogeneous nonlinear differential equation. This is taken from Trench, section 2.4, problem number 30. Y primed equals y cubed plus 2xy squared plus x squared y plus x cubed over x times y plus x quantity squared. The first thing we're going to do is multiply both sides by y plus x quantity squared to y cubed plus 2xy squared plus 2x squared. Oh, not a 2. It's just an x squared y plus x cubed all over x. I'm going to go ahead and FOIL this side and separate this side so that I have y squared plus 2xy plus x squared times y prime is equal to y cubed over x plus 2y squared plus xy plus x squared. Now from here we're going to go through and divide everything by our highest power of x, which is an x squared, so that we have y squared over x squared plus 2y over x plus 1 times y prime is equal to y cubed over x cubed plus 2y squared over x squared plus y over x plus 1. This is equal to, oh, no, I don't want to do that yet. So we're going to go ahead and let u equal y over x. We're going to substitute that in here. So we end up with u squared plus 2u plus 1 times y prime equal to u cubed plus 2u squared, that's a terrible 2, squared plus u plus 1. This is equal to u plus 1 quantity squared, and this is equal to u times u plus 1 quantity squared plus 1. So this would be times y, and this was equal to this. So now we're going to go ahead and divide through. So we're going to have y prime is equal to u times u plus 1 quantity squared plus 1 divided by u plus 1 quantity squared. If you separate and cancel the matching variables, we end up with y prime is equal to u plus 1 over u plus 1 quantity squared. Now from this, we can then say that y is equal to ux, and that y prime is equal to u prime x plus u. So if we go ahead and substitute that in here, we will get u prime x plus u equal to u plus 1 over u plus 1 quantity squared. We're going to go ahead and subtract u from both sides, so that we have u primed x is equal to 1 over u plus 1 quantity squared. And now what we need to recognize here is that we can go ahead and separate our variables, because this is also equal to du over dx. So I'm going to make some space. So then we will divide by x and multiply u plus 1 quantity squared, so that we have u plus 1 quantity squared du equals 1 over x dx. We're going to go ahead and integrate both sides. This is just going to be u plus 1 quantity cubed over 3. And this, as we know, is ln absolute value of x. We do need our variable c here. We're going to go ahead and multiply both sides times 3 so that we have u plus 1 cubed equals 3 times natural log of the absolute value of x plus c. You could go ahead and have the 3 absorb into the c and create a c2, but I found when I did it that it really just didn't make anything any neater as we went through. So the next thing that I'm going to do here, now that we are done with this, get rid of that too. All right, so we're going to substitute back in for u so that we have y over x plus 1 quantity cubed is equal to 3 times the natural log of the absolute value of x plus c. Now, when you go ahead and FOIL out y over x plus 1 quantity cubed, you end up with obviously a pretty long equation, but after you do some simplification, it comes down to being y plus x cubed equals times x cubed, over x cubed, my apologies, equals 3 times ln absolute value of x plus c. We go ahead and multiply both sides by x cubed, and we get y plus x quantity cubed equals 3x cubed times ln absolute value of x plus c. And it is okay to leave it in this form because that is what the problem asks for. And that is one way to solve a nonlinear homogeneous differential equation.